Assalamualaikum. Hello. Again, we're going to look at the next topic, which is Western intensification and how we describe Western boundary current and Eastern boundary current. We have ocean gyre. So this is the western sides of ocean gyre. So we're going to describe how these two sides of this ocean gyre are very much different. So there's 5 ocean gyres. It looks simple, it looks very straightforward. So you can say that South Pacific Ocean is moving counterclockwise, and then North Pacific Ocean moving clockwise directions. But actually there's more into it. So there's one term that you need to remember, which is very important in describing this ocean gyre and to describe the difference between Western boundary current and Eastern boundary current. That's what we're going to learn in this lecture. So the term is Western intensification. So what happened is, Western intensification is actually shifting those center of the gyre slightly to the west. So in this case, if you look at here, so if you imagine this is a North Pacific Ocean, so you can see the center of the gyre, in the theory should be in the middle, but actually in the reality, it is actually shifted to the west. So why that happens? So there's a few reasons and a few factors that are causing those to happen. But to give you a much clearer idea is, so in these all ocean basins, so you have all the center of the gyre moving to the left or to the western sides of the oceans, and it creates a lots of difference. So it creates difference between the western boundary currents and the eastern boundary currents. So that is the most important things that we need to understand. So I'm going to explain to you there's 3 important reasons why Western intensification happens. So one of the reason is because the Coriolis. So Coriolis is actually 0 at the equator region. So what happened is it increase as you go up. So Coriolis force increase as latitudes increase. So when you have this current system moving from the equator region and to the north, so you get the increase of Coriolis. So that's why it start to get stronger. So it gives more strength to the western boundary current. All right, and then the second one is the landmass. So if you look at here, so the current starts here and then gathering the strength, and then it start to reach some land masses over here. So it was not disturbed at the beginning stage. Alright, so it able to accumulate the strength and then move stronger as it reach the land masses, because land masses tend to reduce the strength of current. But if you look at the eastern current, as it goes into the eastern area, it start to get to reach the land masses over here. So it start to lose some of the strength. So that's why eastern boundary on the eastern side you get less strength to compare to the western side. That's landmass. And then the third one is because of the wind. So the wind strength is changing between latitudes. So that's one of the reasons why you have Western intensification is tend to move stronger in the western side and the eastern side. But of course, the biggest and most important thing is Coriolis, because obviously the Earth is moving. So the northern when the Earth move, the floating things tend to move to the western side. So that's why you have western side squeeze and get more strength in these sides of the ocean gyre. So again, so this is the example. So you have a general circulation based on our theory, but the reality is it center of the gyre move to the west and it squeeze. So that's where you have a very strong western current in the western sides of the oceans. compared to the eastern current. So this is western current, boundary current, and the eastern boundary current. So western boundary current is very narrow, very strong, but eastern boundary current very slow, but it's very wide. So this is the best example that you can see, images showing you how in the North Atlantic, where you have a Gulf Stream, so very strong current, one of the strongest current in the world, move very strong and very deep. But on the other side, in the Canary current, you have a very broad, shallow, weak currents of Canary on the other side in the eastern boundary currents. So that's the difference. So you have one strong current on the western side, broad, weak current on the eastern side. So western boundary current form in the western because of the western intensification. So it carries warm water to the poleward. It flows very fast, warm currents, bringing warm waters to the northern hemisphere. It is narrow and deep. There's no coastal outwelling in these currents. So examples of this current system are Gulf Stream, Albornoz current, Kuroshio current, East Australia current, and Brazil current. So you have eastern boundary current in the opposite sides, where it opposite in almost in every characteristics. So this is Gulf Stream. So you have a very strong current from the satellite images showing you how warm waters are being moved to the northern parts of this ocean system. So that's why you have a very temperate northern Europe to compare to the northern Canada, because of this warm water is moving and being pushed to the other sides of the oceans. So you can see those Gulf Stream and what they call as the meanders, because of that's the nature of the ocean currents. When it's very strong, it starts to create it's this like snakes like meanders. Another example from the Kuroshio current in Japan. So again, Japan also shows there's a very strong Kuroshio current bringing warm waters along the coastal area of Japan. Alright, so this is the eastern boundary current. So it formed due to western intensification, but it brings cooler water, slower, cold currents. It's very broad. But one of the interesting things about eastern boundary current you need to always remember is it brings coastal outwelling system. So when you have a very broad and cool waters, so it brings higher productivities waters to the area, and outwelling will bring those waters up and create high productivity regions. So it doesn't happen in the western boundary area, because western boundary area is very deep. It brings warm water with less productivities. So that's the basic concept of western intensification. When you have western intensification, then you start to have a very strong western currents, and then a very weak eastern boundary current, because it's shifted and squeezed to the western side.